This is a brief video for Lab 12, the review for the second culminating lab. There are 4 experiments that you did in the second half of Physics 271, and the culminating lab will only cover those 4. The first experiment you did in the second half of Physics 271 was Lab 8 on a photovoltaic cell. You can see the setup here. There is a photovoltaic cell with a diffuser cap on the end. You should always run with that cap on. And it's hooked up with the output coming out here in the back to channel 1 of the oscilloscope. And there are 2 different light sources that you actually looked at. You looked at an incandescent bulb, and you looked at the LED light source. And the first part of the lab, though, what you did was measure the current voltage characteristics of the photocell. You used the output from the wave generator, the DC output, and the scope to measure voltage, and you measured the current going through the photocell using the multimeter. The circuit is somewhat complicated, and I don't know if we'll ask you to do that, but you can certainly take a look at it. You should take a look at it in the manual. And the idea was that the stronger the light was that was incident on the photocell, the more current you'd see for a given amount of voltage. And in fact, the output current should be proportional to light if you're working in a certain limit, light intensity. The other thing you did in this lab was look at the output of light, or use the photocell to measure output light from this LED source. And as you can see on the oscilloscope, you should have seen, in fact, that it was a pulsing source, and the duration of these pulses is what actually controlled how bright you see or how bright you perceive that light as being. The last part of the lab, you measured the intensity of this source, this photovoltaic source, as a function of distance from the photovoltaic cell. So basically, you can slide the source, the light source, further away from the light and see how the output from the photovoltaic cell changes. And that gives you a direct measure of intensity as a function of position. So fairly simple lab, although some of the concepts are not so simple because the photovoltaic cell is an active nonlinear system. Of course, you use it in another lab or two in polarization and other parts. The next experiment is experiment 9, which is on polarized light. You can see the setup here. On one end is a diode laser. On-off switch is kind of down here on the bottom. It's turned on now. You can see a little bit of red coming out. There's a fixed polarizer and an adjustable polarizer behind it. There you can see that polarizer is at 0 degrees, or it's going to let light through that's oriented straight up. There's also a thick glass plate, which you can let light reflect off of, and that light here is going into our photocell, and there's a diffuser on front. You can see actually the laser beam hitting there. And of course at the back here we have a screen just to stop the beam from transmitting right through. And this part of the apparatus was used for, with everything here, was used for measuring Brewster's angle and the reflected light off of a dielectric, the glass plate. You also had another part of the experiment where you didn't have the glass plate in here, and just measured the intensity of the light as it went through the polarizer when there was a different angle, or when you changed the angle of the analyzing polarizer with respect to the incident light polarizer here. And in that case, you removed the glass plate and swung the detector around so that the light went straight in to the photodetector without the glass plate in the way. So anyway, that's an apparatus for measuring polarization, like in Lab 9. This is a setup for experiment 10, interference and diffraction. There are a few key components here. The diode laser down on one end of the optical track, and then a holder which you can put in single slit patterns, double slit patterns, or diffraction grading. There should be 3 slides. Got one of them up here and 2 on the bench. And you use the webcam then to look at the resulting diffraction images. And ordinarily you will want to have the lights off to do this because the room lights are putting out too much interference to see clearly the pattern, and you can see a little bit of diffraction pattern here. So you use the webcam to record the pattern on the screen, and you could calibrate the measurements with a 1 centimeter grid here, and measuring the distance, say, from the diffraction grading to the screen. That was one key thing. And also, I think you had to record how far the camera was from the screen. And finally, there's Lab 11, which was on optical spectroscopy. And for this, you used digital spectrometer, which was connected to a fiber optic probe. You can see kind of here. And that probe was on a support. In this case, right now, it's looking at light from a hydrogen lamp, and there was a carousel which also allowed you to look at, there's neon, or let's see, what else do we have here? It's hydrogen again, and here was helium. And obviously you can see those colors of those lights look quite a bit different. And you could run a Logger Pro measurement on this, basically output, or the output of the spectrometer. It tells you the intensity at different wavelengths, and here in the case of helium you can see different lines. There's a prominent line right here at yellow, and a couple of other lines that you can see, or a few other lines you can see in the spectrum. And for the different elements, when you're looking at the atomic gases, this would then allow you to find the emission spectra. You also looked at light emitted by a lamp, just the same desk lamp that you've been using to kind of light things up when the rooms are dark. And most of these experiments, of course, have to be done, and these optical experiments have to be done in the dark just to get a clean signal. And you also looked at the light from the LED, which you've used in a couple of the experiments. And you know, this you can again turn on. There's a button here on the side. And you can go white light, which is what it is now, blue, green, red, etc. There's a control panel on the back to adjust that. And you can use the optical spectrometer, again, to focus on that light, or to look at that light and analyze it and display the results. In the case of the white light lamp, you can also look at the output of the lamp, what its spectrum looks like. It's continuous, not a line spectrum. And its shape or intensity depends strongly, the shape of that spectrum depends strongly on the temperature of the bulb, which you can adjust basically by turning the knob on the bottom. So that was the black body part of the spectrum. Fairly simple setup and apparatus, very quick data taking, and you shouldn't have real trouble with this experiment. So that's it. Good luck on the review and the exam the following week.